Okay, so in this video I'm talking about objective 5.4, which is multi-step trig equations. Specifically, we're going to talk about solving with the quadratic formula. Those are problem type D. We're only going to do one example this time. Most of this type of problem just comes down to whether or not you can use the quadratic formula. So if that's something you're having trouble with, look it up, make sure you remember what the formula is, and just try some basic problems that are just quadratic formula and not trig. Now, if the trig is the part you're having more trouble with, I recommend you go back and watch some of the other videos that I've made, specifically types A through C. They might be helpful to you because I go a little more in depth on the trig part. So I just want to show you one good example of how the quadratic formula works with this. Now there is a song, I'm not going to sing it, but the quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Now that is the quadratic formula. I trust that you have it memorized, but if you haven't, make sure you do, because we do use it often enough that it's one of the formulas that you do need to know. There are a couple of differences, but it's very minor. Of course, we're not talking about solving for x in this problem. We are talking about solving for cosecant theta. It doesn't have to be cosecant theta. It could be sine theta. It could be sine x. It could be cosine u. It could be any letter, any trig function. The idea is the same. I've got a quadratic trig equation. I need it to be in the form ax squared plus bx plus c equals 0. So it needs to be equal to 0. I need to have it in descending order of my quadratic term, my linear term, and my constant term. Or in this case, cosecant squared, cosecant, and then I need this constant term on the other side. So that's going to be our first step for solving this problem. We need to subtract the 3, so turn this into 2 cosecant squared theta minus cosecant theta minus 3 equals 0. So that looks better. And now we can check for a GCF. This one doesn't have one, but it's a good idea to check for a GCF up front for all your quadratic formula problems. We're going to say a equals 2, b equals negative 1, and c equals negative 3. And then cosecant theta will equal negative b, which is negative 1, plus or minus the square root of b squared minus 4ac, which is 4, 2, and negative 3, all over 2a, or 2 times 2 in this case. So cosecant theta equals negative, that's a positive 1, plus or minus, simplify this a little bit, 1 squared, negative 1 squared, will just be a positive 1. Negative 4 times 2 is negative 8, times negative 3 is positive 24. Now this particular problem will actually result in this being a perfect square. I will briefly touch on what happens if it isn't one in just a moment. And then 2 times 2 is 4. So cosecant theta equals 1 plus or minus the square root of 25 over 4, or cosecant theta equals 1 plus or minus 5 over 4. That's the square root of 25. So we get cosecant theta equals 6 over 4, and cosecant theta equals negative 4 over 4, which is equal to negative 1. From here, this is a one-step trig equation. You're going to take the reciprocal, turn these into sine, and then figure out what theta is. If you need more help with that, I recommend you go watch the video over objective 5.2, which was problem type A. And that will tell you how to finish this type of problem. But I'm really more concerned about solving these quadratics. So, what would happen if you ended up with a problem that looked more like this? Sine theta equals negative 6 plus or minus 4 square root of 11 over 10. Now this is reduced as far as it goes. I can't take anything else out of here because this is prime. There are no more perfect squares that come into this problem. what you need to do at this point, because I still need to figure out what is theta. I don't care what sine theta is, I want to know what theta is. So turn this into a decimal very carefully. So we're going to say sine theta equals -6 plus 4 square root of 11 over 10, and sine theta equals -6 minus 4 square root of 11 over 10. And then we will say -6 plus 4 radical 11. Be very careful about how you type that in. And just so I don't make any mistakes, I'm going to hit enter now. And then I'm going to divide by 10. So we get sine theta equals 0.727. And that is something I can type into my calculator. Likewise, I will do sine theta equals -6 minus 4 square root of 11. Hit enter. Sine theta, well, I need to divide by 10 still. Sine theta equals -1.927 on that one. In this particular problem, sine, I know, can't be less than -1 because of our unit circle. So I can throw this one out, and it's just a matter of figuring out what is theta by doing inverse sine and then figuring out where does that value repeat. So we're going to say inverse sine of 0.727. I get 46.64 degrees. That's in quadrant 1. Sine repeats across the y-axis. So my other one will be 180 minus that answer. And I get 133.36 degrees. So those would be your two answers for this one. So if you get a radical that doesn't reduce, turn it into a decimal, and then just use your calculator.